Hi everybody, I'm Professor Marco Marengo and I'm going to speak about the activities we are carrying out in our research group. These activities are, let's say, linked to what the Center for Regenerative Medicine and Devices is doing. So it's not all what we are doing in terms of the complete palette of research we are carrying out, but this part is more related to the microfluidics experimental activities and multiscale multiphase numerical simulation. Part of this presentation is also covered by Manoli Andredaki, Vahid Bazargan, and Giordana Peregrino. So I'm not going to enter in the details, but to give more an overview of our activities. See here on the left the work that Manolia is doing on the absorption of exudate in porous structure. And on the right, we have simulations at the nanoscale. So imagine that the cube here has a side of 370 nanometers, and the duration of the simulation is 10 nanoseconds. But I think that this can be interesting in nanofluidics or to understand nucleation problems in mixture, for example, and also, of course, in porous structures. This work is linked to the activities, the experimental activities of Simon and Rachel, and again Manolia, about the exudate absorption and the viscosity effect. This is very interesting in order to understand which is the best dressing, for example, for the exudate. We are working also with molecular dynamics. Here is the work that we have published in 2020 in Physical Review Letters, and is about the nanoprinting. So we have nano droplets impacting on surfaces, and we are understanding what is happening in terms of wettability. This can be linked to, for example, to the entrapment of viruses or bacteria in very small droplets, environmental droplets or aerosol, for example. On the right, we have an experimental work on the droplet impact onto edges. This is only to show that we are able also to have high-speed camera recordings, which can be interesting also for pharmaceutical processes or, let's say, medical processes and so on. We worked a lot with the VOF simulations also for droplet impact onto spheres. This is linked to encapsulation problems, or for example, droplet impact onto meshes. Again, this is linked to the filters, for example, dressing again, and so on. We have a running project, 3D MED project, that is about the concept, the design, and the construction of a kind of 3D printing machine for pills, for personalized medicine. Vahid Bazargan will speak more about this project later on. So, what we can offer to the Center for Regenerative Medicine and Devices, we can work on simulations, as said, DNS simulation of microfluidic systems. We are also very interested in working in direction of, for example, of blood circulation, or for example, microfluidic lab-on-chip devices. Fluids on nanosurfaces, especially related to the wettability problems. Fluid dynamics in porous materials, like the dressings, but also thermal control of components, like, when you want to have a needle, isothermal needle, for example, dealing with mixtures, drugs. And the last topic is about the controlled Doppler generation, again using microfluidic devices. This was very fast, short, but I hope that I was able to give you an overview of the possible links with the research in the Center for Regenerative Medicine and Devices. Thank you.